I bought a stainless steel part and it rusted. Could it be fake? Hey, detailed engineering. Imagine the following scenario. You bought a stainless steel part and it started to rust. Then you wonder if they sold you something fake. After all, stainless steel doesn't rust, right? This is a common frustration, and the answer can be both yes and it depends. Today, let's separate myth from reality and explain why some stainless steels rust. How can you identify materials that pretend to be a 304 stainless steel but aren't? And what can you do to avoid being fooled? But after all, what is stainless steel and why shouldn't it rust? Stainless steel is a type of steel with enough chromium, at least 10.5% chromium, to form a passive, very thin and adherent layer of chromium oxide. On the surface, this layer acts as a self-sealing shield. If it's scratched, it rebuilds itself in the presence of oxygen and prevents rust from spreading. In 300 series steels like 304, this protection is reinforced by nickel in the range of approximately 8 to 11%. But wait, if stainless steel protects itself, why does rust sometimes appear? Not all oxidation on stainless steel means the steel is bad or fake. There can be surface contamination by steel particles, for example, from a steel brush or metal dust from cutting. It may have been specified incorrectly because there isn't just one type of stainless steel, there is actually a range of products. In other words, there are different types of stainless steels with different levels of corrosion resistance, and knowing how to specify the correct steel for each intended environment is essential. That's why an incorrect specification can cause major problems. Now, there's a scenario where the chance of corrosion increases a lot. When the material they sold you as 304 is actually a steel from the 200 series, the famous fake 304. And what is fake 304 and why is it a problem? In recent years, steels from the 200 or 2XX family have been circulating in Brazil, being advertised as 300 series or type 304. These steels were designed to reduce costs by replacing part of the nickel with manganese, and the result is a cheaper material but with inferior corrosion performance in many everyday conditions. While genuine 304 has about 8 to 11% nickel, the new 2XX series steels sold as 304 have around 1% nickel. And this difference is crucial for corrosion resistance. But why does reducing nickel worsen the corrosion resistance of stainless steel? A lot of people think that nickel is like a coating, but actually it works inside the alloy, stabilizing the austenitic phase and helping chromium do its job better of maintaining an intact passive film. And when that nickel drops too much and it's compensated by manganese, the material can even maintain austenite. But the corrosion resistance, especially in solutions with chlorides like in kitchens, coastal applications, and washing areas, tends to drop. In tests, in practice, 2XX steels usually show a higher susceptibility to pitting and stress corrosion in environments that 304 handles more easily. In simple terms, less nickel usually means a higher risk of stains and pitting where you didn't want to see rust. And chromium, it also changes from a true 304 to a fake 304, yes. And that matters. Typical 304 has about 18% to 20% chromium, while many 2XX grades work in the range of 13% to 16%. It may not seem like much, but removing chromium weakens the ability to form and maintain the passive film, especially in brushed or sanded finishes, or when there is contact with salts and bleach. Since the protection of stainless steel depends directly on chromium, this reduction, combined with lower nickel, creates the perfect storm for rust to appear sooner, and it doesn't stop there. In several compositions of the 200 series, the carbon content is higher than in 304, which increases the tendency for sensitization, that is, the formation of chromium carbide, and this paves the way for intergranular corrosion. In addition, sulfide inclusions associated with sulfur are preferential initiation points for pits. But then, how can you protect yourself when buying and not get fooled? The first defense is clear nomenclature. Explicitly look for IC 304 or UNS S30400 and supply standards, such as ASTM A240 for sheets and strips. Be wary of vague descriptions like Series 300 without specifying the type, and of obscure trade names when the seller avoids saying 304. Be alert to designations from the 200 series, 201, 202, and similar, including market variants like the so-called Series 300, which are low nickel alternatives. For important purchases, ask for the quality certificate with the composition, and it should show nickel in the 304 range as well as the appropriate amount of chromium. Some of these steels are sold under model names like the so-called Series 300, which suggests that it's an ASI 304 series steel. ASI 304 represents a standard established by the American Iron and Steel Institute for a chromium-nickel austenitic stainless steel. Recognized for its robustness and excellent corrosion resistance, it is used with a strictly controlled chemical composition. On the other hand, the so-called Series 300 is a designation for stainless steel developed to be a more economical alternative, but it does not follow traditional standards. Since it is not governed by a specific international standard, as is the case with standardized ISI 304 steels, it can actually be said that it is a commercial designation. Linking the 300 series to pass as 304, this modification results in a material with lower cost but with lower corrosion resistance in more aggressive environments compared to the real AC 304. And that rule, which applies to almost everything in life, is relevant here. When the offer is too good, you should be suspicious. In other words, a price that's too good to be true almost always means low quality, and it doesn't stop there. In some low nickel alloys, copper is added in higher amounts to adjust properties for materials and equipment that come into contact with food. In Brazil, Anvisa's RDC resolution number 20 sets the limits. And these metallic materials must not contain more than 1% of impurities made up of lead, arsenic, cadmium, mercury, antimony, and copper considered together, and the individual limits for arsenic, mercury, and lead must not be higher than 0.01%. Since the pseudo 304 contains copper at a considerable level, this raises an additional warning for food use. And in case of doubt, request reports and avoid critical applications. But then the question remains, I bought stainless steel and rust has already appeared. What should I do in practice? First, try to remove surface contamination with proper cleaning, neutral detergent, warm water, and a non-abrasive sponge. Always clean in the direction of the finish and avoid using steel wool. It leaves free iron particles and makes the situation worse. Next, if necessary, use a stainless steel passivator based on nitric acid, always following the manufacturer's instructions to restore the passive film. If the part becomes stained again quickly, especially with pits, reassess the environment, such as the presence of chlorides or the use of cleaning products, and contact the supplier, requesting the chemical certificate. And if the composition indicates Series 200 sold as 304, do you have a technical basis to demand replacement? In the end, when stainless steel rusts, can you say it's fake? Not always, but the probability increases when the application is typical for 304. The maintenance is correct, and even so, pits and persistent stains still appear. The design difference between 304 steel and many 2XX grades explains why fake 304 is more susceptible. And the key is to combine good design and choosing the right grade for the environment, proper finishing, correct cleaning, and above all, checking the nomenclature and composition before purchasing. With these precautions, stainless steel goes back to being what science delivered: a durable, hygienic, and corrosion-resistant material for everyday use. If you've made it this far and enjoyed the video, take the opportunity to subscribe if you haven't already, hit the like button, and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. And if you want to know more relevant and technical information about stainless steel, point your phone at the QR code on the screen or click the link in the video description. They will take you to a website about real stainless steel, which is where the inspiration and information for this video came from. There, you will find a lot of relevant technical information to help you avoid problems with your stainless steel. Have you ever had a stainless steel pot that rusted? Did you know that maybe you bought a material that was out of specification? Share your experience in the comments, I want to know, right here on the side. There are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave your like, subscribe to the channel, activate the bell, and consider becoming a channel member. That's it, engineering lovers, take care, and I'll see you in the next video.